I'm going to start sharing my entire screen so you guys online can see my calculator too. So I'm not going to go into the graph. I'm just going to use the function so I don't have to do all the arithmetic by hand. I'm going to clear anything out that's in. So I'm putting y1 as the position. So x cubed minus 3x squared. Everybody all right there? Okay, so I'm going to go back to my paper for a second. So I know if I'm trying to find the displacement from 2 to 0 seconds, I want the calculator to do all of this for me. If I had to do it by hand, which isn't bad, I would take 2 and I'd plug it in here, figure out what number I get out. I'd plug 0, I'd do it in there. I'll show you one time so you know what it is that we're doing, but I want to make sure you know the shortcut. So I'd find x at 2. X at 2 is 2 cubed minus 3 times 2 squared. So that's 8 minus 12, so I get -4. So this piece would be -4. I would do x at 0. If I plug 0 in, I get 0. So I get -4. So I know the change in x over the first 2 seconds should be -4. And let me show you how we could do that on our calculator really quickly. If you have your position function in, and again, I would do this because I know I'm going to be evaluating it at several numbers. So then I hit second quit and go to my main screen. I want to pull up y1 since y1 is that function, the position function. So I hit alpha and then trace, and then I select y1. And I'm just going to enter it in like what I had on my paper. So I want the position evaluated at 2, so I put it in parentheses. And then I pull up position again, so that's alpha, trace, y1. I wanted the change in position from 0 to 2 seconds. Sure enough, we get -4. Am I surprised that it's negative, or what do you guys think about the negative? Did we expect it to be negative? Why?
Velocities.
Very good. It's in the interval where velocity is negative. In this interval, we were moving to the left. If you're moving to the left, it makes sense that we have a negative displacement. We ended up 4 units to the left of where we started. Okay, let's do the same thing for where we were moving to the right. So if we want to figure out how far we were moving to the right, I would need the change in position over that time. So I would do the position at 5 seconds minus the position at 2 seconds, because that was the interval when we were moving to the right. So now on our calculator, we'll type that in. So on my calculator, I'm going to go alpha trace. I need y1 at 5 minus alpha trace y1 at 2. Again, I chose 2 and 5 because that's the interval where it's moving to the right. I got a positive number. Is that what I expected? Yes, because it was moving to the right. So now I know the change in position to the right was 54. So it moved 4 units to the left and 54 units to the right. So what is the total distance? 58. So the rule is you're actually taking the absolute value of the -4, right? Because you don't want it to become negative. You don't want to subtract it off. So the total distance is 58, I don't know, feet.
I think it was centimeters.
Was it centimeters? Thank you. Did this question ask us for the displacement at some point?
Yeah.
Yeah, on part A. What did you guys get as your answer on part A? What was the total change from 5 seconds to 0 seconds?
50 centimeters.
50? Notice that should make sense because 50 would have been if we added those two together without taking the absolute value. So yeah, -4 plus 54 is 50. So yeah, the displacement is 50, but the total distance you add them together. Yeah, Milo.
So how come you're not doing them in order? Like
I always do final minus initial.
So do D or E, then go up.
Oh, no, I'm doing the ones that were asked. That's why. So the only ones that were asked were E and G. So my hope was that you guys were okay on the first few since they weren't listed. So that's why I didn't do them.
Oh, where does it say we only want E and G?
So there's a link on Canvas, just to make sure everybody knows. So I take questions from here. So the hope is that So there's this link right here. It says submit questions for AB. So you guys list your questions, and then I take the questions that are listed. So since I saw 24, 5E, and 5G, my hope is that I don't have to do the whole question, basically. But in order to do it, I had to do, only E was asked, but in order to answer E, we had to know D.
I think you're just
Yeah.
selecting. Yeah, okay,
Yeah.
thank you.
So then the next question, normally you're right, I would definitely go in order. Okay, so the next question that was asked was G. F, nobody asked F, but it does just say find the average velocity, but average velocity is specified right above. So I think that one's not bad. It wants the average velocity from 0 to 5. Let me just show you what I would show for F. So on at F, average velocity, I always just think change in position over change in time. So I like to write it out like that. So it would be the position at 5 minus the position at 0 over 5 minus 0. So from part A, you already found the change in position was 50 centimeters. So you traveled 50 centimeters and you traveled 50 centimeters over 5 seconds. So it makes sense that the average velocity is 10 centimeters per second. So that's average velocity. Okay, average speed. What's the only thing that's different between question F and question G is it went from velocity to speed. What's the difference?
Speed is the absolute value of velocity.
Very good. Speed is the absolute value of velocity. Now, I guess it does change because we do have to consider total distance. But it shows it to us there, and we already found total distance. So average speed, we do have to consider how far we've traveled. So on G, average speed, you need total distance, but now we've answered that over, how did it say, elapsed time. I'm going to say change in time. What was our distance traveled over those 5 seconds? 54, well, I think it was 58, right? So our total distance we found to be 58 centimeters. So we traveled a total of 58 centimeters, and we did that over 5 seconds. So our average speed is this. You could reduce and get a decimal, or you can just leave it as 58 over 5 centimeters per second. Okay. The other question that was asked was number 6. Okay, so 6 gives us a graph. These ones go faster as long as you understand what it is that you're looking at. So when you first get a graph, always pay attention to, like, this is time and this is velocity. So if you were to pick a point, I'm just going to say a point, who can describe in words, what is this point? I want to make sure we understand this graph. That point has a coordinate of 4, -2. In context with this problem about a particle moving, what is it saying at that point? 4 represents what? 4 what?
Seconds or time units into.
Good. I guess they didn't even give us time units, but 4 in the time units. So let's just simplify it and say it's seconds. So this is at 4 seconds. What does the -2 represent? Velocity, because this axis represents velocity. So at 4 seconds, it has a velocity of -2. So at 4 seconds, is it moving right or left? Right. I heard 2 answers. I heard both. Left. Why left? Good, because velocity is negative. If you have a negative velocity, it's moving to the left. Okay, I just picked a point at random, but that's kind of a good idea to do when you have a graph. When you're given a graph, make sure you understand the graph that you're looking at when you start, which can just be as easy as picking a point and making sure you understand what that point is talking about. So when does the particle move left? Anytime I see move left, something about left or right, I know that that's referring to velocity. Moving to the left if velocity is negative. So velocity is negative anytime velocity is below the x-axis. So that's from this time to this time. That x-intercept is easy. What's that one? Guess what? We have to know for sure. I don't want just an estimate. How do I know for sure what that x value is? What was your estimate? What would be a reasonable estimate? 1/4. 1/4 is correct. I know it's 1/4 because what's the slope of that line? -4, down 4 over 1. So if we went down 4 over 1, then yeah, if we go down 1, we're over 1/4. So you can kind of use the slope to make sure. If I'm going to be super specific, another like long way of doing it is you could write the equation of that line. I could say, okay, the slope of that line is -4. Name any point on this line. What's a point on that line? There's several, just pick one. Are you okay if I say 0, 1? Everybody agree that point's on the line? So I could write the equation, -4 x minus 0 plus 1. The point I'm trying to find is right here. At that point, y equals 0, and I'm trying to find the x value. So I could set this equal to 0 and solve for x. But if I solve for x, yeah, I'm going to make -1 and divide by -4, so I get 1/4. Okay, so they're never going to be that tricky, but you do, if it is an x-intercept of a linear function, they do expect you to actually find that value. So it's moving to the left from when t is between 1/4 and 7 seconds. Are we all right with that? That's where the graph is below the x-axis. Okay, let's do part B. They want positive acceleration. Okay, I just realized I want a lot more space. Okay, positive acceleration. Let's first talk about what is acceleration. How have we defined acceleration? If you had an equation, how would you find acceleration? Very good. Acceleration is defined as the derivative of velocity. But we're looking at a graph, so what is a derivative? What's a derivative mean? It's the other word we use a lot. Slope. So it's really the slope of velocity. Okay, so if you're looking at a graph, acceleration would be the slope of velocity. So we want acceleration to be positive. So if we want acceleration to be positive, we want v prime to be positive, or the slope of velocity to be positive. So where does the slope of this graph, where does that have a positive slope from what time to what time? Good. From 4 to 8 seconds, that's where the slope of velocity is positive. So I'd say this happens when t is between 4 and 8 seconds. Okay, on C. C talks about speed. What have we said? What is speed equal to? Very good. So if I graph, I'm going to sketch a graph. I'm going to sketch a graph of the absolute value of this function. So I'm going to take this graph. I'm going to try doing it right next to it. I graph speed. Anything that's positive stays positive. So the little piece that was already above the x-axis to a fourth was positive. The piece below, it's kind of that trapezoidal piece, flips. It comes above. This was at 7. And then the triangle that was above stays above, and then it's just like that. Not bad. So we can sketch a graph of speed. If you sketch a graph of speed, then this isn't bad. So the question just says, when is speed the greatest? Well, looking at this, it's the greatest up here. So that would be from this time to this time. What are those 2 times? Kind of have to look back at the other, at 1, yeah, because that was this point got flipped and this point, so 1 to 4. So speed is the greatest when t is between 1 and 4 seconds. Yeah.
Could you write your answers just like parentheses?
Yeah, exactly. Yep. So it'd be fine to say 1 to 4 like that. Yep. Okay, when does the particle stop for more than an instant? When you hear a particle stops, what comes to mind? Not necessarily flat, it depends on what kind of graph we're looking at. So ignore this graph for right now, just in general. If it says stop or at rest, what always is true? What's 0? What equals 0 if it's at rest? Velocity. Okay, so it really is important, I think, to not consider the graph yet. Just think, what are we looking for? It's stopped when velocity is equal to 0. That's the case whether we were given an equation or a graph. Well, if we're looking for where velocity is equal to 0, and this is a graph of velocity, it says, when is it stopped for more than an instant? Well, it's stopped for more than an instant, looks like from 9 to 10, because velocity is 0 in that interval. Velocity has a y value at 0. So I would say in t is between 9 and 10, or you could use interval notation. Okay, so that was 6. And the last one was 12. Okay, so 12 is just a review of finding a derivative. This will get us close to what we have to do soon. Wait, I don't remember. Have we learned product and quotient rule? Okay, so it's coming up. I get confused with A, B, and B, C, which classes have learned which things. Okay, I wouldn't use it anyway on this one. I want to simplify. So I would rewrite this as 2x times what? What is the square root of x? How can I rewrite the square root of x? Good, x to the 1/2. And then I would think, okay, well, 2 to the 2x is really x to the first power. You're multiplying common bases, you add the exponents. So this would be 2x to the 3/2, because 1 plus 1/2 is there. Now the derivative is super easy. So now we take the derivative. The 2 stays, the 3/2 comes down in front. We minus 1. If we minus 1, we're back to 1/2. I'm going to simplify a little since I do have to plug in a number. So I have 3, and then x to the 1/2 is the square root of x. They want us to evaluate it at this point. So what are we plugging in for x? 4. The 16 is just extra information. If we plug in 4, square root of 4 is 2, so 3 times 2 is 6. Not bad. Okay. That's all they asked us to do. Yeah, they just wanted us to evaluate the derivative at the point. Okay, let's go ahead and go on then. Did we have any others? Okay, so we're going to switch. Oh, good. Speaking of product and quotient rule, this is what we learned today. So that's probably why that question was there. So product and quotient rule. I need to remind myself really quick what I put on here. Okay. So we'll do all of the examples today, and then tomorrow we'll just kind of take some questions. There's only 4 examples. These are not difficult. They're just formulas that you have to memorize. I could go through proofs of why these work, but I'll show you one example. In fact, we'll do one both ways. Okay. So product rule is used when you have 2 functions that are being multiplied together. In fact, I want to do the example that came up on your quiz from last Friday. I want to show you that one because some of you tried to do product rule with it, and I'll do it both ways. Okay, so product rule is applied if you have like one function times another function. The rule is you do the first function times the derivative of the second, and then the second times the derivative of the first. This notation is like mathematically correct, but I like how it's written out here because F stands for the first function, S stands for the second function. So to me, it's easier to memorize it when it's written like this. So I always say it to myself when I do this. So the derivative of 2 functions is the first times the derivative of the second. That's what S prime stands for, is the derivative of the second. And then the second times the derivative of the first. Okay, so product rule. So I'm going to do an example with product rule first. Does anybody have their quiz handy from last Friday? I know it was question 2. Question 2 from your quiz. I can look it up. Oh, have I even handed yours back? I did, right? Okay, good. Lance, do you have yours by chance?
Question 2, find the derivative of y equals 2x. Parentheses, x third minus 2, close parentheses.
Okay. You guys remember this question? What did you do? How do you take the derivative of this? Distribute. Yeah. So you can distribute, and if you distribute, you would get 2x to the 4th minus 4x, right? And then you would take the derivative, and if we take the derivative, we get 8x cubed minus 4. So this is how we've done it previously. I want to show you how we could apply product rule to this exact same question. Okay, so I could take this function. There's a first function and a second function. So I'm going to say, here's the first, and here is the second. Product rule is this. This is what we just have in our notes. So the first times the derivative of the second plus the second times the derivative of the first. Okay, so I'm going to find y prime. So what is the first function? What will I write for f? 2x. Okay, s prime stands for the derivative of the second. What is the derivative of the second?
3x squared.
Great, so I could multiply by 3x squared. Then it says add the second. What's the second term? What do I write for S? Great. So that's the second function. And then I times it by the derivative of the first. What's the derivative of the first? 2. I want to show you that these are equivalent. Okay, so if I multiply these two, I'd get 6x cubed. If I distribute this 2, I would get 2x cubed minus 4. Dun, dun, dun. Do you see how we get the exact same answer? So there's y prime. What way is easier? Yeah, this way is definitely easier, right? If we can avoid product rule, we're going to avoid product rule. Okay, so you would multiply those together. The mistake I saw on the quiz, I saw a lot of you guys, not a lot, but at least 5 or 6 people take this. Let's see, there's the 2 in front. And they said, well, this derivative is 2 and this derivative is 3x squared. So they said, oh, then the derivative is 6x squared. Remember, we cannot just do that. You can't just take the derivative times the derivative. If you have 2 functions, your choices are either multiply the 2 functions together and then take the derivative, or follow product rule. Okay, so let's do product rule on the example in our notes. Let's do this first one, and then we'll look at quotient rule. So I know that it would be quicker if I wasn't practicing product rule. I probably would just multiply those together and take the derivative, because that would be faster. But I want to show us that I want us to practice product rule one time before we have to work with really ugly functions. So product rule, I'm going to say this is my first function and this is my second function. I would say until you have it memorized, I think it's really helpful to just write the formula down. So first times the derivative of the second plus the second times the derivative of the first. I'm going to write it almost every time so everybody knows like where I'm pulling values from. Okay, so f prime, I need the first function. What's the first function? What do I write for f?
3x squared minus 2.
Perfect. Notice I'm just going to keep it in parentheses. There's the first function. Then I need to multiply it by s prime. S prime, that stands for the derivative of the second. What's the derivative of our second function? 2. So I times it by 2. I add the second function. Again, keeping it in parentheses. And then f prime, what does f prime stand for? What's that mean? Good. And what is the derivative of the first? 6x. Very good. And then I just simplify this. So I'll distribute the 2. If I distribute the 2, I'd have 6x squared minus 4. Distribute the 6x, I'd have 12x squared plus 18x. I can combine like terms and I'd get 18x squared plus 18x minus 4. Always label your answer, so make sure you call this f prime, which is found f prime. Okay, so that's product rule. I'm going to do it the other way just so we can see if we got the same answer. So the other option, which normally I would do, is I would multiply them together first. You guys don't have to write this because I'm going to delete it in a second. So if I multiply, I'm going to rewrite f of x first. What's that first product? 6x cubed. Okay, you guys stop me if I make a mistake. I get 9x squared. The inner product, I get a minus 4x. The last product, I get a minus 6. I could then just take regular derivative, right? Power rule, 18x squared plus 18x minus 4. What do you know? They're the same. So again, in general, yes, most of the time in your assignment, it's going to, ask you to do it both ways today. Product rule, or just multiply first and then do it. On a test, you get to choose. Okay, let's do quotient rule. Quotient rule looks pretty ugly. Okay, but you have a top function and you have a bottom function. So this first like long ugly thing is like the mathematically correct notation, but this is an easier way to memorize it. What do you think T stands for? Top. Yeah, so the letters make sense. B then would be bottom. So when I say this, I'm talking about the top and the bottom. One major difference, notice the sign. On product rule, it's a plus, and on quotient rule, it's a negative. Well, most things when we have a quotient rule question, it always turns into a negative. And we start with the bottom. Okay, you do have to have these formulas memorized, but you're going to use them so much, it's pretty easy to memorize them. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. Okay, so again, my recommendation as you do these questions, just be writing it out. So I'm going to write it out. So y prime, the rule is bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. So now I'll just plug stuff in. So B, I need the bottom. Keep it in parentheses. The bottom is 2 minus 3x. And then t prime. What is t prime? What does that stand for? Derivative of the top. So what is the derivative of the top?
4x minus 4.
Good. Just make sure you keep it in parentheses. So far I've done the bottom times the derivative of the top. The formula tells me to put a minus, so I put a minus in between. And then I have the top, also in parentheses. And then we multiply by b prime. B prime would be the derivative of the bottom. What's the derivative of the bottom? Negative 3. It's all over the bottom quantity squared. Good news, you will never have to simplify the denominator. So always leave the denominator and not like quantity squared. The numerator, it's a little bit algebra. Yeah, Milo. I got negative 3 because that was b prime. So b prime stands for the derivative of the bottom. So I took the derivative of this, and the derivative of that, let's call it b prime, is negative 3. Because
So
that goes away.
when you
And
put b on the very top,
uh-huh,
you didn't need to prime it out.
exactly. This one is just the bottom without the derivative. And then when I write b prime, it's the derivative of it. Yep. So then it's just your algebra skills, right? We just have to multiply and simplify. So you guys make sure I don't mess up. I'm going to FOIL this together. That gives me 8x. The outer product gives me a minus 8. Inner product, I've got a minus 12x squared. The last product, I've got a plus 12x. Then I'm going to do this like next set. What stands out to me is I have a negative here and I have a negative 3. So I'm really multiplying by a positive 3. Are you guys okay with that? I'm basically distributing a positive 3. So I'm going to take care of this and this at the same time. So this would turn into a, let's see, a plus 6x squared. Multiplying by a positive 3, so it stays negative. So a negative 12x and a negative 9. No, a positive 9. You guys double check, do you agree?
Sign just doesn't change.
Only on this particular one. And what I probably would do actually is I would actually physically change it. I'd say, okay, I'm going to multiply those together first and then distribute this way. Yeah. Okay, now I'm going to combine like terms. If I combine like terms, I have those two can combine, so I get a negative 6x squared. I have 8x, 12x, and a negative 12x. That just leaves me with an 8x. Then I have a negative 8 and a plus 9. You guys agree with my numerator?
Usually cancel the negative 12 squared.
I crossed it out, sorry, but it was combining this and this together. Yeah. And then it's all over the bottom. Remember the denominator, never, ever, ever multiply it together. Always leave it as a quantity square. We just found y prime. That's our answer. Quotient rule, most of the time we can't avoid it like we can product rule. Like we didn't have another option on this one. This is the only way we could have found the derivative.
Why can't we factor out the bottom?
You could, but it's just a lot of work. So like if you had to, if you like what it means to square something would be to multiply this by itself.
It doesn't really matter.
Yeah, we never want it like that. We always want it in factor form. So in fact, we always want it listed just as that factor squared. Yeah. Okay, so let's look at 3. This one we could do in 2 ways. We could do quotient rule. So I want to show quotient rule first so you can see how it works, and then I'll remind you how we could have done it previously. So this is our top. So this is our top, and this is our bottom. I'm going to write out quotient rule. Quotient rule, it'll help you memorize it the more times you write it out. Quotient rule is bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Then we just plug stuff in. Okay, so y prime. What's the bottom? What do I plug in for the bottom? Good. As always, I keep it in parentheses. So there's the bottom. And then t prime, I need the derivative of the top. What's the derivative of the top? 0. Formula tells us it's a minus the top times the derivative of the bottom. What's the derivative of the bottom? Good, 10x. Yeah, sorry. 10x. And then it's all over the bottom after I just lectured you about never boiling it out. If it's a single term, I'd square it. That's easy. Okay, let's simplify the numerator. So y prime, this is 0. So the numerator, I have a negative 90x. All right, that's that. I've got a negative 90x. The bottom, because it is a single term, I would square it. If you guys are okay, I'm saying it's 25x to the 4th. Can we reduce that? What, 18 over 5? 5 can go into both. 5 can go into negative 90 18 times. 5 can go into 25 5 times. And then the x's could reduce to an x cubed. Really all right? Yeah. Probably. It would be. Thank you for catching that. You're right. We have a negative times a negative, so you're right. That needs to be a positive.
Wouldn't the end have to be negative?
No, because it's just multiplying these together. So, like you multiply these two and then by that. Like you don't distribute it unless there's a plus or minus. Okay, I want to remind you though, you've done the question like this before and you've used a different method. You had one like this on your quiz, in fact. Lance, do you still have your quiz handy?
Yeah,
What was it? Was it number 3?
yeah.
What was number 3 on your quiz?
1 over x.
You guys remember this question from your quiz? We didn't do quotient rule. What did you do? Yeah, so we rewrote this as x to the negative 3, and then we did the derivative, and we're able to just do power rule, right? I'm going to do that on this example. So let's rewrite this. How can we rewrite y so that we can do power rule? Good, and we would only move the x squared, right? I'd leave the negative 9 over 5. That doesn't change, but I could write it as x to the negative 2. If I take the derivative, I could do power rule, which would be this power comes down in front. If I pull down a negative 2, I'd have the negative 9/5 times the negative 2. And then I'd minus the power, so what's the new exponent? Negative 3. Sorry, this is the derivative. If I simplify, well, there's the 18 over 5. X to the negative 3 goes to the bottom. And what do you know? They're the same. So you can avoid quotient rule if you can bring the x up to the top using a negative. This way was faster, right? In purple, it's faster if you can avoid quotient rule, but you will get the same answer either way. Okay, so let's do our last example. When it's e to the x or sine of x, this is where you're not going to be able to avoid product rule because you can't actually simplify this any further like you can a polynomial. What is our first function? What would I identify as the first function? Very good. So that's the first function. Then what's the second function? Sine x. So product rule, practice writing it out. It will help you memorize it. It's first times the derivative of the second plus the second times the derivative of the first. Okay, you just have to memorize that formula. So g prime, what do we write for f?
3 to the x.
Great. And then s prime, cosine. Good. This is why we had to memorize these. The derivative of sine we have memorized as cosine. And I guess these parentheses aren't really necessary, so I'll just leave it like that. So that was first times the derivative of the second plus the second. Well, the second is just sine x times the derivative of the first. What is the derivative of 3e to the x? 3e to the x. So I think this is good. It's giving you a chance to practice those previous derivatives. Guess what? The nice thing is we're done. I'm fine. You can leave your answer like this. This is it. So sometimes these ugly ones are almost easier than polynomial because you don't simplify. Yeah, Milo.
Is the derivative of 3x always that?
Yes. Yep. Use is often
Oh.
the only function that is its own derivative.
Okay, so it's e.
Yeah. Yep. Okay, I will show one thing. This is the way you can leave your answer, but on a multiple choice, they might do one thing to it. If they ever simplify, it's often by factoring. Do you see anything in common from this term? That's all one term because it's a product. And this term, what do they both have in common? They both have a 3e to the x. You guys agree with that? They both have that piece. So on a test, you might see this on a multiple choice with that 3e to the x out in front, and then a cosine x plus sine x. On your homework, I don't care which way you write it, just recognize that those two are the same. Okay, so that's as far as that's the only line you have. Okay, your assignment, I think I said 1 through 15, but let me just double check. Yep, 1 through 15. Okay, so your 2-5A is questions 1 through 15, so you're gonna score it out of 30. What you'll notice is, notice questions 1 and 2, it's the exact same function, right? But on 1, it wants you to use product rule, and on 2, it says without using product rule. How do you do it without using product rule? What would you do on 2? Boil it. Okay, so it's just kind of making you practice both ways so that in the future you can choose whichever way you want, that you're comfortable doing it both ways. Okay, 3 is quotient rule. The rest of them I think are pretty okay. Keep in mind when you get down to 12, it says it gives you a C, but C is a constant. That just means treat C as a number. So if I just asked you to take the derivative of x squared minus c, what is the derivative of x squared minus c? 2x. Because the c is a number, we don't know what the number is, but it doesn't matter, we go away. Okay, so I'll let you guys work. So you do still have 12 minutes. I think that's enough that you could get through probably the first 4 questions before you go. Have you guys taken care of your AP payment? I need to hassle any of you. Let's see who I haven't given these to. I think you guys are.
So we're good to go?
Yes, you guys online. If you feel good, you can log out.
All right, thank you.
Okay, if you have not, I would put a reminder in your phone. Tomorrow's your last day this week that you're in the building. So you don't want to remember this on Friday and have to drive to the school to pay. So set an alarm in your phone if you haven't paid to make sure to bring your money, pay in the main office tomorrow, or call the main office so that you can pay on Skyward. But again, the penalty is about as steep as it can be. It's a $40 late fee if you don't pay on time. So that's huge percentage wise.